The purpose of this lab is to determine approximately how much excess charge is on one piece of charged clear tape. For the first part, we have two pieces of tape that are charged and interact both with each other and other charged and neutral objects. For the second part, a piece of clear tape is suspended in the air by a second piece of clear tape that exerts a force, causing it to float. The physics fundamentals for this lab includes Newton's first law, the idea of electric field and force, and gravitational force. As we recall, Newton's first law means an object at rest remains at rest unless acted on by an unbalanced force. For us, this means that the net force is equal to 0. The electric field is equal to kq over r squared in the direction of r hat, where r is the distance between a charged particle and an observation point. And the force on another charged particle by that original charged particle is equal to q times the electric field of the original charged particle. And we recall that gravitational force is equal to mass times our gravitational constant in the negative y-hat direction. As a preview of our results, we found that the tape was positively charged and that charge was at any point about 4.6 times 10 to the negative 10 coulombs. For the starting conditions, I created two equally sized charged pieces of tape, and I predicted that the two pieces of tape would repel each other. The system included the tape, and the surroundings were the objects I brought near the tape, for example, my hand or the clear pen. So here are my answers to the questions for part 1 of this lab. Overall, the results show that the tape did repel each other as predicted, that the tape was attracted to most neutral objects, and the tape was attracted to the clear pen, which was negatively charged, indicating that the tape is positively charged. A point of potential error is that the clear pen I use was not sufficiently charged, and that in fact it was neutral. At the start of part 2, tape B is stuck to two ends and lying across a gap, and tape A is far enough away to not influence tape B. In this part, the system is tape B, and the surroundings were tape A. The assumptions I made were that Fnet is equal to 0 and equal to the gravitational force on tape B plus the electric force due to tape A. I found that the mass was about 0.008 grams using the ratio of 0.001 grams per inch of clear tape. I also assumed that each clear tape had the same net charge because they had the same approximate shape and size and were the same material. And given that is true, that every point on the tape should have the same balance of forces acting, therefore we only really need to focus on one point for good calculations. And here I have shown my free body diagram, and I use the Fnet equation to solve for Q, which I got as 4.669 times 10 to the negative 10 coulombs. Based on that answer, I also found the electron deficiency, the number of atoms, and the ratio of electron deficient atoms to the total number of atoms. For my GlowScript code, I use a modified version of Lab 0, including Fnet is equal to the gravitational force plus the electric force of tape A. I created a separate sphere for tapes A and tape B, and created arrows representing the balanced forces. Again, I assumed that Fnet was equal to 0. I ignored air resistance. I treated the tape as if it were a point charge with all the mass and charge concentrated at a central point. Some potential errors of this part include that the distance between tape A and B could have been inaccurate. I based it off of a few attempts, which were approximate because the tape seemed to discharge after a while, and possibly tape A and B had different charges, since tape B was connected to a cardboard box. Okay, what if electrons had a positive charge and protons had a negative charge? In this case, assuming that protons still don't move, that means that the positive charges move in neutral objects when the charged tape comes close. So like charges would still repel, opposite charges would attract. And since the tape had electron deficiency, it would now be negatively charged. And why is it important to handle the charged tapes as little as possible? Well, since the charges are evenly distributed through the tape, the charge could also distribute onto my hands, diluting the charge on the tape itself.